Welcome to Mathematics Online Lecture Series, lecture number 19. Change of order of integration in double integrals by Professor Kevin Nelson. Today we will discuss about another problem, problem number 10. Evaluate the integral by change of order of integration. Integral 0 to 1, integral x to root over 2 minus x square, x by square root of x square plus y square dy dx. So if you observe this integral, so first integral in terms of x variable, now this is y. Now other variable is x, which is clearly written here. X integral x is 0 to 1, integral y to root over 2 minus x square, x by square root of x square plus y square dy dx. Now actually integrate first, integrate with respect to y, then integrate with respect to x. But in change of order of integration, interchange the roles of the two variables. First integrate with respect to y, then integrate with respect to x. Now this methodology is called change of order of integration. So now what is the methodology? First find out the given region. What is the given region? Region of integration. Now find out, now change of order of apply change of order of integration, then find the limits. Then third step, evaluate the integral. Evaluate the integral. Now for this purpose, first we will find out the region, then we will find out the limits for change of order of integration, then finally we will evaluate the integral. Now what is the region of integration? Now lower limit is y equals to x, upper limit is y equals to square root of 2 minus x square, x limit 0 to 1. So if you squaring on both sides, this is nothing but x square plus y square equals to 2 and y equals to x. Now this is a straight line, this is a circle whose center at the origin, and radius is root 2. Now this is a circle equation, radius is root 2. Now y equals to x is a straight line. Now if you observe, what is the integral value? X to y equals to x means is this line to circle, okay. Then x limits, x equals to 0, okay, but here this is root 2 comma 0, okay, but x limit is 0 to 1 only. Now what is 0 to 1? So if you find the point of intersection of these two, if you put y equals to x equals to 2x square equals to 2. Now x square equals to 1. Now x equals to plus or minus 1. Nothing but this point of intersection is x equals to 1, y equals to 1. Now another point of intersection is this one, this is not required. So x is 0 to 1. In this integral, line to this line to circle, then x is 0 to 1 is nothing but this shaded region, so which is shown here. So point of intersection is y equals to x, x square plus y, substitute x, y equals to x square plus y square, 2x square equals to already discussed here, x equals to 1 comma minus 1, then y becomes 1 1, points of intersections are 1 1 and minus 1 comma minus 1. Okay, now another one, this point of intersection, point of intersection of y-axis and circle. Very simple. Y-axis is x equals to 0. If you put x equals to 0 here, x equals to 0 here, y square becomes 2. Y square becomes 2 means y equals to plus or minus 2. So this point is B. This point is A. Now red color region is our region. This region is our region. This is our region. Now this is our region. Here O is our region. Now the red color region is our region. Now change of order of integration. Change of order of integration already discussed. First x limits, then y limits. If you want to find the x limits, observe along x-axis. Now this region starts from here. This point is nothing. This curve is nothing but x equals to 0 to this one is nothing but x equals to y. Okay, but observe the total. If you observe x equals to along x-axis, some circular curve, some straight line curve. Now it is y or circle. So this is very difficult to find. So half part is straight line, half part is circle. So for this purpose, divide into two regions like our previous problem. Now observe this one. So the total region is divided into two regions. Upper region is R1 and lower region is R1. In upper region, along x-axis, x equals to 0 to circular curve, and in the lower curve, x equals to 0 to straight line. So the total region is divided into two parts, R1 and also R2. So now again we will evaluate the integral for R1 region and also R2 region. For R1 region, upper region, now what about the x limits? X equals to, now this is starting point, this is curve, x equals to 0 to circular curve x equals to square root of 2 minus y square. Now x limits, I power x is 0 to along x axis. Now y limits, here y equals to 1 to 2. Y equals to 1 to root 2. 1 to root 2. So which is shown here. X limits 0 to square root of 2 minus x square. Y limits 1 to root 2. Okay. Now for the lower region, what about the x limits? Here again, y-axis to this curve, y-axis is nothing but x equals to 0 to this curve is y. Now what about the y limits? Here y coordinate is 0, here y coordinate is 1, 0 to 1. For the lower region, x limits 0 to y, upper region 0 to 1. So now we will evaluate the integral by separation of two regions, R1 region for R2 region, then add the two integral value, you will get the total value. Now we will evaluate the integral. Now this is a given integral 0 to 1, integral y x to root over 2 minus x square, x by x square plus y square dy by dx. Now this is first separated into R1 region, this is R2 region. For R1 region, x limit 0 to root over 2 minus y square, already here discussed, y limits 1 to root 2, 1 to root 2. Now integrand is x by square root of x square plus y square dx dy. For the lower region R2, x limit 0 to y, 0 to here, 0 to y. Now y limits 0 to 1. Okay, fine. Now, so using the limits. So first we integrate with respect to y, then with respect to x. This is nothing but change of order of integration. Actually, with respect to y, then with respect to x. Instead of this method, we are changing the order. First with respect to x, then with respect to y. Here also same procedure. For this purpose, first integrate with respect to y. For this purpose, separate x terms inside, then separate the y terms. X integral here multiply and divide with 2. 1 by 2 times of integral 1 to root 2, integral 0 to 2 root over 2 minus y square 2x by root over x square plus y square dx. Now the integrand is both are same and limits are changed. Now if you put the denominator equals to x square plus y square equals to t, x square plus y square equals to t, 2x dx equals to dt. 2x dx equals to dt. So this integral dt by t, dt by root t. dt by t integral dt by dt is 2 root t. 2 root t. T means this one. X square plus y square 2 root over x square plus y square limit 0 to 2 root over 2 minus y square. Here also same because both integrands are same. Now limits are different. Now 1 by 2 and these two cancel. This 2 and 2 cancel. Now put x equals to root over 2 minus y square. X square means 2 minus y square plus y square minus lower limit. If you put x equals to 0, root over y square becomes y. Here also, if you put x equals to y, so y square plus y square is 2y square. You now minus sign. For the lower limit, x equals to 0, root over y square equals to y. Okay, this is not required. Already substituted. Okay. Now, if you observe here y square cancel, you will get root 2. Integral y is 1 to root 2 minus y dy plus integral y is 0 to 1 root 2 into root over y square is y. Here also y is the common root 2 minus 1 into y. Now integrate with respect to y. Now it is very simple integration. Here constant term. So integral is y. Integral y equals to y square by 2. Limits 1 to root 2. Now integral y is y square by 2. Root 2 minus 1 is the constant and coefficient. Now limit 0 to 1 here. Here 1 to root 2. Now first put y equals to root 2. Root 2 into root 2. Root 2 whole square is 2 by 2 minus lower limit 1 into root 2 minus 1 by 2 plus if you put y equals to 1, 1 by 2 root 2 minus 1. If you put y equals to 0, 0. Now if you observe root 2 into root 2 is 2, over 2 by 2 is 1. Here minus root 2, minus or minus plus 1 by root 2, 1 by 2. Here root 2 by 2, 1 by 2 minus 1 is 1 by 2. This one cancel. So you will get 2 minus 1 is 1. Then minus root 2 plus half root 2. So this is nothing but simply minus half root 2. Minus half root 2. So root 2 cancel. This is nothing but root 2 whole square. 1 root 2 cancel. You will get 1 by root 2. So 1 minus 1 by root 2 is the answer. Very simple. The similar way we will evaluate the another problem. Problem number 11. Evaluate the integral by change of order of integration. Now this is quite interesting problem and very simple. Integral 0 to 5, integral 0 to 4 by x, xy, dx, dy. Now this is y in terms of x limits. Now it is y, this is x. So it is clearly written x is 0 to 3, y is 0 to 4 by x. The region of integration, y is 0 and y equals to 4 by x equals to 3 and x equals to 5. Now what about the curves? If you observe x, y. Now y equals to 4 by x is inverse function. Now this is look like this one, inverse function. Okay. Now x equals to 3 to x equals to some 3 here, x equals to 3 here, x equals to 5, x equals to 5. So this middle region is our region. So y limits 0 to 0 by 0 to means this curve up to this one 4 by x. This is 4 by x curve. Then x is limited now, which is clearly mentioned here. This is inverse function 4 by y equals to 4 by x. Now x equals to 3. At x equals to 3 on y-axis, if you put x equal to 3, y coordinate is 4 by 3. At x equals to 5, 4 by 5. Now this is the total region. So the point of intersections are also very simple, already discussed here. Very simple. We now substitute x equals to in this curve and x equals to 3, we will get the points of intersection already clearly mentioned here. Now, the total region, again, region is divided into two parts. Now, this is up to this one. This is curve, then straight line. So, again, it is divided into two parts. This is first part, this is second part. Now, for the both the parts, apply change of order of integration. Now, first x limits, then y limits for R1 region. In the similar way, like our previous problem, R1 region from this one to this one. This is nothing but x equals to 3 to this curve. From this one, x equals to 4 by 1. 4 by 1. Now y limits, here if you observe, this is when x equals to 5, this is 4 by 5. This point is 4 by 3. So y limits from this one to this one, 4 by 5 to 4 by 5 to 4 by 3 for R1 region. So x limits 3 to 4 by y, 3 to 4 by y limits 4 by 5 to 4 by 3. Already discussed here. For R2 region, now what about the x limits? Along x-axis. Along x-axis, this is a straight line to straight line, x equals to 0, 3 to 5. Y limits along y-axis. Here y equals to 0 up to this line. This is nothing but 4 by 5. 4 by 5. So y limits, x limits 3 to 5, y limits 0 to 4 by 5. Now again divide into two parts. Now I will apply the change of order of integration. So this is the given problem. X is 3 to 5, y is 0 to 4 by 5. Now divide into two parts. First part is R1, second part is R2. For R1 region, x equals to 3 to 4 by 5. X is 3 to 4 by 5 and y limits 4 by 5 to 4 by 3, 4 by 5 to 4 by 3. That's for the lower region, x equals to 3 to 5 and y is 0 to 4 by 5. So 4 by 5. Now first integrate with respect to x, then integrate with respect to y. So this is change of order of actually integrate with respect to y, then integrate with respect to x. Now changing the order. First integrate with respect to x, then integrate with respect to y. Now changing into two parts and apply the corresponding limits. Now for evaluation of the integral, first integrate with respect to y. For this purpose, separate the x variable and y variable. Here integral x is x square by 2, limits 3 to 4 by y. Here again x square by 2, limits 3 to 5. Now put x equals to 4 by y whole square by 2 minus x equals to 3 square by 2 into y dy plus integral 0 to 4 by 5. Put x equals to 5 square by 2, then minus x equals to 3 square by 2 into y dy. Now simplification. This is 16 by 2. 16 by 2 is 8 by y square. 8 by y square into y is 8 by y. Now 9 by 2 into y, 9 by 9y. But here plus 8 into, now observe if you simplify 25 by 2, 25 by 2 minus 9 by 2, 2 is a common LCM. Then 16 by 2 is nothing but 8. 8 into y dy. Now this is very simple. Limit is y 4 by 2, 4 by 5 to 4 by, here 0 to 4 by 5. Now integral 8 by y, 8 into integral 1 by y equals to log integral y equals to y square by 2, already 2 here, limits 4 by 5 to 4 by 3. Here integral y equals to y square by 2, then 0 to 4 by 5. Now put y equals to 4 by 3. 8 into log 4 by 3 minus 9 by 4 into 4 by 3 whole square minus, now second limit 8 into log 4 by 5 minus 9 by 4 into 4 by 5 whole square. Here put y equals to 4 by 5, 8 in, here 8 to cancel 4, 16 by 25 minus 0. Now if you observe, Here 8 into log 4 by 3, here 8 into log 4 by 5. Now if you common 8 log 4 by 5 minus 4, log 4 by 3 minus 4 by 5. Here 4 cancel, 3 cancel, you will get minus 4. Now this, say if you simplify, you will get this term. If you simplify, you will get this term. Now if you simplify, these two are, this is totally cancelled because minus 4 plus this is 100 by 4, 100 by 25 is nothing but 4. 4 minus 4, this value is 0. Now if you observe, this one is log m minus log n. Log m minus log n is log m by n. Log 4 by 3 by log 4 by 5. So 4 cancel. This is nothing but 8 log 5 by 3. 8 log 5 by 3. Now this is also another very interesting problem. So in the next lecture, we will discuss about the applications of double integrals. Quite interesting problem. So we will we will apply the double integrals for solving the real world problems. Thank you. Thank you very much. If you have any doubts, contact email or phone number. Thank you. Thank you very much. Meet again.